All right. So now we're moving on to section 4.5. I think this section's a little easier because they don't go into the more complicated graphs. They keep things pretty basic. But anyway, what we're going to do now is we're going to be looking at a graph, and from the graph, we're going to try to create the equation that created it. So we're kind of going backwards now. So just a couple things. In this section, they're only dealing with sine or cosine. So this is just sine or cosine. We're not dealing with tangent, cotangent, secant, or cosecant. So that's good. Okay, A, remember that this is the amplitude. Now, if it's not centered or if it's shifted around a bit, you can always find the amplitude by just using the following equation. You have the peak y value minus the valley y value and you divide that by 2. So if it's not centered, but usually you can look at it and tell what the amplitude is. As far as this goes, the K, this is just the vertical shift. And so that tells you that if it goes up or down. Now here we're looking at it a little differently. Instead of saying bx plus c, what they did is they factored the b out. And if you factor the b out, you're left with x plus, and then you got something kind of right there. And they're just calling that negative h. Or in this case, the minus is built in. So they just have an h there. The reason why they're doing that is because remember in the last section, the phase and the horizontal shift were different. They had different meanings. And so if you write it like this is the horizontal shift. You can look at it and just tell immediately what it is. Okay, and that tells you if it goes left or right. Oop. I'm not going to go too much into that. Now, B, this is the period. So remember the formula that this comes from is the period. I don't have room, so let me extend it down here. The period is 2 pi over b. So if you solve for b, I'm just going to do it in one step. But if you solve for b, you end up with the equation that b is equal to 2 pi over the period. So if you look at your equation and you can see what the period is, you do 2 pi divided by that, and that gives you the b. And so we're going to combine all these ideas and see if we can create our equation. So we're going to start with two really basic examples first. So let's look at this first example. If you look at this, you ask yourself, what does this look like? Does this look like a sine, or does this look like a cosine? Well, looking at it, you can tell that it starts at 0, 0, and sine's the only one that does that. So this is a sine wave, and then you have to ask yourself, okay, is it flipped or is it normal? And based on, we know what the shape of sine is, so I know it's not flipped, so it's a normal sine wave. All right, and then you have to ask yourself, are there any shifts? Basically, does it go up or down? Does it go left or right? And the answer to this is no. It's a normal sine that starts at 0, 0. And sine starts at 0, 0. So there's no up, down, no left, right. So I don't have to worry about that. What this means is that h is 0, or the up, down part means k is 0, h is 0, these variables up here. All right, and now we just have to figure out a and b. So since there's no shift, I can see that the amplitude is just the height from the middle all the way to the top. So I know that the amplitude is 2. And I can figure out what b is because I know that b equals 2 pi over the period. Well, if I look at this, the period is 2 pi. So b is 1. So I have everything I need. I know h and k are 0, a is 2, b is 1. I know it's a sine wave. So my final equation is just going to be 2 sine of x. Sine of 1x, but I don't need to write the 1. And that's it. Easy cheesy. So now we can move on to the next one. One thing to notice is you look at it and you say, okay, is it a sine or a cosine? I'll just put sine, I'll put cosine here. And so looking at it, you can tell that this is not a sine, it's a cosine. So now that we know it's a cosine, is it normal? Or is it flipped? Well, cosine usually starts at the positive side. And since this starts down on the negative side, I know that it has to be a flipped cosine. Okay? But notice that there's no shifting. The amplitude, the middle of the cosine is right through the x-axis. So there's no shifts. So that means that h is equal to 0, k is equal to 0. So if the middle is right through the x-axis, that means it doesn't shift up or down. It started right at the y-axis, or right at x equals 0. So that means there's no shifting left or right. So no shifts total. I can look at it and see what the amplitude is. The amplitude starts up here, goes on there, so I know my amplitude is equal to 3. And now I can figure out what my b is. So b is 2 pi over the period. Well, the period is from 0 all the way to 8 pi. So my period is 8 pi, and that's just 1/4. Okay, so 2 pi over the period. Yep. And so I can write my answer. So my answer for this, since h is 0, k is 0, I know it's flipped, so it's going to be -3 cosine 1/4 x. And there we go. -3 is the or 3 is the amplitude. Since it's flipped, it's a -3. Cosine, because that's the shape of the graph. And I found the number in front of x is just 2 pi over the period. So 2 pi over 8 pi is 1/4. There we go. All right, so I'm going to do 2 more. And these are going to be more complicated. They're going to shift around. So to help us with that, I made little tables for each one. And we're going to do these 2, and then you're going to do the next 2 on your own. All right, so these are more complicated. Identify the following trig functions in terms of sine and cosine. So one thing to notice is it depends on how you're looking at it, if you want to look at it as sine or cosine. So if you want to start at the beginning, then you can say, oh, well, there's one cycle, and so that is clearly a cosine. But if you wanted to view it like this, then you can say, all right, well, that is clearly a sine wave. It depends on how you want to look at it. And it doesn't even notice that this is an upside down sine wave. But if I wanted to, I could have started over here. And that's a right side up sine wave. So there's really no wrong answer for these. It all depends on your original starting point. All right, so my phone's blowing up, so I'm going to pause real quick so I can see what's up. But I'll get back to the lecture in a bit. All right, so let's go back to this. Okay, so again, we can choose wherever we want to start. My first one, I'm going to do cosine, because like I mentioned before, it starts right at 0. And starting right at 0 means that there's no left or right shift. So for this one, we have no left-right shift. And that means that h is equal to 0. And notice that it's right in the middle, so there's no up-down shift. Okay, so that means that k is equal to 0. So let me go ahead and fill that in. If we're using cosine, then the vertical shift is 0. Horizontal shift is 0. The amplitude is just from the middle to the edges. So I'll just do it right here. And we can see that that's, if this is 1 and there's 5 tick marks, that's just 4/5. So my amplitude is 4/5. Now B, we notice that the period, just from looking at it, we can see that the period is 2 pi over 3. So that means that B has to follow a formula. Remember, B is going to be 2 pi over the period. Now, in your calculator, you would have to put this in parentheses. But notice the 2 pi's cancel. And if you work this out, you're going to end up with just 3. So the second thing to notice is that normal are flipped. Well, a normal cosine looks like that. And that's what my graph looks like. So it's normal. And so with all this information, I can come up with my answer. My answer is going to be positive 4/5 cosine, and B is 3, so 3x. And that's it. That's your answer. But again, the starting point determines everything. So let me see in my notes which route did I take here. Yeah. So if I erase all this, well, I don't want to. Yeah, I guess I have to. No, you know, I don't really have to. Let's say I start here instead. Notice if I do that, I end up with a positive sign. It's a normal sine wave. Again, I could have started over here, but that would have been a negative sine wave, and I just want to make the equation look as nice as possible. So I can erase that. There we go. All right, the amplitude is still 4/5. That doesn't change. Okay, and the period, it's still the same sine wave. I mean, it's still the same wave, so the period's the same. But if you really want to know and want to get an idea, each tick mark in this is pi over 3. And notice this starts right between 2 pi over 3 and pi over 3. So if I add the two and divide by 2, basically I'm taking the average. I get 3 pi over 3 over 2. 3's cancel. Pi over 2. So this middle point right here is pi over 2. And it's going all the way to, this would be pi. And this would be 7 pi over 6. This is using the same idea, taking the average between the two. And so if you wanted to, you could figure out what the period is by subtracting. But again, it's the same wave. The period's still going to be 2 pi over 3. But if you wanted to, you could subtract 7 pi over 6 minus pi over 2. That's 7 pi over 6 minus 3 pi over 6, which is 4 pi over 6, which is 2 pi over 3. So notice that it's the same one. In the next example, say if you're dealing with the same wave, the period's going to be the same. So I'm not going to have to redo the calculation every time. But I know that the period, so it's still going to be 2 pi over the period. And that's still going to be 3. All right? Now, as far as shifting goes, this one did have a shift. Notice that it's shift right. So vertical shift is none. Again, no up, down. So that means that k is equal to 0. Okay, but the graph did go to the right by pi over 2, because that's where my sine wave started. Since it went right pi over 2, this h is just pi over 2. I don't like the way that looks. But anyway, let me get my mouse kind of shifted a bit. All right. Yeah. So that's a plus pi over 2, positive. So now when I write my equation, the equation for this is going to be 4/5, because that's the amplitude, and it's a normal sine wave, sine, parentheses, and then I put my b, 3. But remember that we're dealing with, whenever we write it out, it's going to be b parentheses x minus h. So b parentheses x minus h, in this case x minus pi over 2. There you go. Now if you wanted to, you could distribute the 3. It's up to you. And that gives you 4/5 sine of 3x minus 3 pi over 2. And that would give you the phase. And just to show you these are the same thing, I'm going to go to Desmos, and I'm going to type in these two equations. And you're going to see that these two equations are exactly the same. And when you're ever dealing with a sine or cosine picture, or a graph of a sine or cosine, you can always reinterpret it as the other trig function. So if I go to Desmos, and so I type in 4/5. Oh, let me get projector mode going. So 4/5 cosine 3x. So that was our graph. And to make it look even better, I can make the x-axis and put it in steps of pi. So now it looks like our graph did. Now I can type in 4/5 sine of 3 parentheses x minus pi over 2. Notice that the two graphs are exactly the same. So anyway, just a heads up that that is totally doable. All right, moving on to this one. Looking at this, if you want to start with the easiest possible trig function you could think of, usually you do one that starts right at the beginning. So here, this starts right at the x equals 0. And so we notice that that's a sine wave. Also, it's an upside down sine wave. Okay, my amplitude, if I look at this, my amplitude is 1.5. I'll just write it out. Now 1.5, since we want to write it as a fraction, is 3 over 2. Okay, this starts at 0, so there's no horizontal shift. The x-axis is right through the middle, so there's no vertical shift either. And now I just got to figure out what b is. So here my period is 1. So that means that it's going to be 2 pi over the period, which is just 2 pi. All right, so all that's done. And so now I can type it in as negative sine, because it's flipped. Oh, sorry. Negative 3/2 sine. And then parentheses, and b is 2 pi x. There you go. And so now I can go to Desmos, I can type that in. Negative 3 over 2 sine of 2 pi x. And let me get rid of the pi scale. And so notice if I make this between, what's my graph between? Oop. It's between 1, 2, 3, 0, and 3. So I can actually restrict this to between 0 and 3. Ah, there you go. And that's exactly the graph that we have in our picture. Isn't that cool? Sure is, Gilbert. Anyway, so that's that. Now, what if we wanted to write it as a cosine? Well, if you look at it as a cosine, let's say the cosine, I want to start at the first possible point. So the cosine would start right there and go right there. So this would be a cosine. Notice it's a normal cosine, or actually it is a flipped cosine. Sorry. So it's a flipped cosine. Now, if you wanted to, you could have actually started up here. It is completely up to you. You could have done it from here to here instead and done a normal cosine. But I'm just starting with the first available spot that I'm given. There is really no wrong answer. The amplitude doesn't change. So that's still 3/2. Oop. Okay, b doesn't change. That's still 2 pi because the period is still 1. Okay, the vertical shift is still 0 because the x-axis goes right through the middle. The horizontal shift is what changes. I have to figure out what this is because that's what the shift is. And so since this is 1, this is just a quarter of the rotation, or a quarter of the shape. So this starts at 1/4, and this would be a fourth past 1, which is 5/4. So my horizontal shift is just going to be 1/4. Okay, and again, remember that you can always split a trig function into quarters. And if I look at the sine wave, the first part that I did, this peak down here occurs a quarter of the way through the cycle. But since the cycle is 1, a quarter of 1 is just a fourth. So I know that has to be a fourth. And from there, I can create my equation. So I have a flipped cosine. So negative 3/2 cosine, 2 pi. But now there's a shift, so it's x minus 1/4. And if you wanted to, you can distribute that 2 pi. So 2 pi x. Distribute the 2 pi. 2/4 is pi/2. So minus pi/2. There you go. So I can go back over here to Desmos and type in negative 3/2 cosine 2 pi minus pi/2. And notice I get the exact same picture. Yeah. All right. So what I want you to do is on the next page, try these out on your own. I want you to try one as a sine and one as a cosine and see if you can get the same exact graph for each picture. All right. And now next, I want to go into 2 more problems. And these ones are shifted a bit. So the only difference between these is that they go up and down. Every example we've had up until now, notice that k has been 0. So anyway, let's do these real quick. Identify the following trig function. So if I want to start right at 0, which gives me the easiest possible trig function. Oh, didn't change colors. Then I have this shape. And notice this shape is an upside down cosine. Okay. The amplitude, a little different. The amplitude is, notice that since the x-axis doesn't go right through the middle, it's a little harder to see. But my peak is at 0. Remember, it's just peak minus valley. Actually, peak plus valley. Peak plus valley. No, minus valley. Over 2. So my peak is 0. I'm looking at the y values. My valley is -4. So minus -4 over 2. And that just gives me 2. So really the middle is right here, if you want to think about it visually. And your amplitude is just from the middle of wherever your trig function is to the edge. And so there, that's why the amplitude has a length of 2. But if you wanted to use a formula, you could always do peak minus valley over 2. Let me make that smaller because that's taking up that entire box. My bad. Uh-oh. My bad. Let me try that one more time. All right, so my amplitude is 2. Now B, I can see that a period is going to go from 0 all the way to this tick mark. And looking at that, there's 4 tick marks, and it ends at pi. So this has to be quarters. So here we have pi over 4, pi over 2. Here this would be 3 pi over 4. Where this tick mark to the left is pi over 4. So it's going to be 2 pi over the period, 3 pi over 4. So we work it out. If you want to do, you can use your calculator, but 4 over 3 pi, those cancel. And so the pi's cancel. 4 times 2 is 8, and you just get 8/3. So this one really nasty with the trig function, or with the number that's in front of it. But we end up with 8/3. All right, there's no horizontal shift because I started at 0. So no horizontal shift, but notice that it went down. The middle of the graph is at -2. So that means my vertical shift is down 2. So -2. So now I can combine all the pieces together. And this gives me a flipped cosine. So -2 cosine, 8/3 x, because there was no horizontal shift, and then -2. There you go. -2 cosine 8/3 x -2. So I'm going to go back to Desmos, so let's type it in. -2 cosine 8/3 -2. And this graph is going from -pi to pi. Let me turn on my tick marks. Let's go by pi. There we go. And so that should be a good representation of our graph. Oh, what did I do wrong? Negative, was it -2? Cosine 8/3 x. Here, let me see, that's not matching exactly what we got here. So let me troubleshoot. Let me pause the video real quick, because Gilbert might have screwed up. Let's see. All right, guys, I figured it out. Really, we were off by just a fraction. If this was on a test, I would have counted it right. So don't be alarmed. But the right answer is 3. And if you go back to our domain, we got 8/3. And how much is 8/3 off from 3? That's just a third off. And the reason is we were estimating. I looked at the graph and I estimated that, oh, look, that's right there at that tick mark. So the period should be 3 pi over 4. But in reality, let me extend this a bit, there's this extra piece that ends perfectly on pi. And so notice that if you start from the beginning and go all the way to the pi, that's a period and half a period. So 1.5 periods, or let me write that somewhere. Let me get rid of this start at x equals 0. Okay. So 1.5 times the period, or 1.5 periods, is exactly pi. Well, if you divide by 1.5, my decimal's really nasty, apologize. You end up with the period is equal to, now 1.5, you can even do 1 over 1.5 in your calculator. If you do 1 divided by 1.5 and math frac that, that's 2/3. So that's 2 pi over 3. So the period wasn't really 3 pi over 4. The period was 2 pi over 3. And that's my fault. And again, and this was on a test, I wouldn't have counted it wrong. Because really you're eyeballing. But when you do 2 pi over 2 pi over 3, you get 3, which means that this is really 3. Okay, so we were off by 1/3 in terms of the period. So, meh. Off by a couple decimal places. I apologize for misleading you there. Yeah, so anyway, that's that one. Excuse me. And again, we had, so let me go back to my cursor. We had 8/3. And if you just add 1/3 to that, 9/3, which is 3, then it's the graph that you see in your picture. So I apologize for that mistake on my part. Okay, so now that we know what this is, we know that the amplitude and the period and the b stay the same. But if I want to look at this in terms of a sine wave, then what I'll have to do is I'm going to have to, let me erase all this stuff. It's going to have to start here and go like that. Let me erase that 3 pi over 4 because that just confused everybody. All right, so notice that it's starting 1/4 of a period later. So I know my period is 2 pi over 3. So from here to here, from here to here is just 1/4 of a period. And so I'm just going to get my period and multiply it by 4. And that gives me 2 pi over 12, which is just pi over 6. Okay, and that's my horizontal shift. My vertical shift is still -2. If I look at this, this is a sine wave. That's normal, not flipped. So I can write this out as a +2 sine of 3 parentheses x minus pi over 6. Remember, the minus is part of the formula. So it's minus a positive pi over 6. That's what that means. And if I go back to Desmos, I can type in that new equation. 2 sine 3x minus pi over, oh, I forgot to subtract the 2. And you can see it's a perfect match. Wah, wah. Forgot the -2. There you go. So again, apologies for that mistake. Let's go to this next one. So here, if I'm looking at this, the first thing I see is this. And so that starts at pi over 4. and then goes to 5 pi over 4. So this is an upside down sine wave. Okay, the amplitude, if I find the middle of the graph, notice that the middle is 3. And from the middle all the way to one of the peaks or valleys, that's just 3. So my amplitude is 3. Or if you wanted to use a formula, you can say the peak is at 6 minus the valley is at 0 over 2, and that just gives you 3. So that's my amplitude. Here, the period is 5 pi over 4 minus pi over 4. So that's just 4 pi over 4, which is just pi. So my b is 2 pi over the period, which is just 2. Okay, horizontal shift, I can see that I went right pi over 4. And vertical shift, I can see that I went up 3. So putting all that together, I can create my equation as flipped. So minus 3 sine b is 2, parentheses x minus pi over 4 plus 3. And so I can type that into Desmos. Let me erase. Oh, it did erase it. Hey, that's cool. All right. So what was it again? Totally forgot. Negative 3 sine of 2 x minus pi over 4, and then plus 3. And this graph goes from pi over 4 to 5 pi over 4. So pi over 4, 5 pi over 4. And notice we got a perfect match. That's what my graph looks like. Yay! So next is to look at it from a cosine point of view. So looking at this from a cosine point of view, you can see this would be the shape we're looking at. And that is a flipped cosine. Now, when you're dealing with the same trig function, it's the amplitude and the period stay the same. So that's still going to be 3. That's still going to be 2. The vertical shift is still plus 3. All that changed is the horizontal shift is plus pi over 2. And so my graph for this one would be negative 3 cosine of 2 parentheses x minus pi over 2 plus 3. So let me go ahead and graph that on Desmos. Negative 3 cosine 2 x minus pi over 2 this time plus 3. Oh, forgot to put that. There you go. And again, if I copy paste this, copy paste, it's the same trig function. In hindsight, I should have put this problem first before the one above it, because that one was trickier. But anyway, what I want you to do is work on these two, see what you get. And again, in real life, if you make a mistake like I did where you're off by just a fraction, I won't take points off because you still theoretically, you did all the right steps and your mental process was in the right spot. Anyway, I'll post the videos for this on Canvas below this lecture. And other than that, you have a good day.